Hello everyone. So today I'm going to be showing you how to bypass UAC using UACMe. So as everybody knows, when you try to open up a program as administrator, you always get this little prompt that says user account control, and basically it notifies the user that this program needs to make changes to the device. But there are actually bypasses for it, which basically allow a program to be run as administrator without triggering the UAC prompt. Now, in order for any of these bypasses to work, the UAC level cannot be set to highest. If it's set to highest, it isn't going to work. If it's set to the default setting or even lower, it's going to work fine. So just make sure that this isn't set to always notify. Anyway, UACMe, just to briefly explain what it is and what it does, it's a project that contains implementations for a bunch of different UAC bypasses. If I go here under keys, there's a whole bunch of them documented here. Some of them have been patched in recent versions of Windows. Some of them will still work. But the problem is the author of this program doesn't want to distribute compiled binaries anymore, and the build instructions are not very good, to say the least. So I'm making this video to try and make this a bit more accessible and explain what you need to do. So we're going to get started by opening up Visual Studio. I'm using 2022, but you can use an older version and it should work fine. Then go to clone a local repository and then copy paste the GitHub URL here. And this is going to clone the entire Git repo, so we have it locally. And then you can see here there's quite a lot going on with the structure, but I would like to show what this looks like in File Explorer first, because you can see it looks a little bit different compared to the Solution Explorer. Okay, so the way that UACMe is structured is it contains different modules, and the different bypasses are sort of split up into different parts that are then built individually. So we're going to go here under Nano Desu, and we're going to build Akatsuki first. And I'm going to build this under release. It doesn't really matter, but I like to build it as release. So we're going to go here and click on build. And it's going to build fairly quickly. You can see it says 1 succeeded. And then we want to build Fubuki. So we're just going to right click on it and click build. And we can also build this one as 32-bit. So we're just going to select Win32 and then build that again. Okay. So now we're going to build Naka. I'm going to build it as x64. Naka is a special tool that acts kind of like a compressor, I guess you could say, for these other modules containing the exploits. So we're going to build Naka, and then we're going to use it. We're going to use the tool to basically compress and I think also encrypt these other modules with the actual exploit. So we're going to go here in this Naka folder, output x64 release, and we have naka64.exe here. So I'm just going to open up CMD here, and we need to pass in, basically, we need to pass in the build output of Akatsuki and Fubuki, and these are actually DLLs. So I'm going to go here under Akatsuki output x64 release, and you can see we have Akatsuki64.dll here. So I'm just going to copy the path and then pass it into Naka. And then I'm going to do the same with Fubuki. So I'm going to go to output. I'll compile the 64-bit version first. So we're just going to copy the path and pass it into Naka. And then do the same for the 32-bit version, obviously. And there's actually one more file that we need to run Naka on. And it's located here in this kamikaze folder. The file is called kamikaze.msc. So we're going to copy the path of that as well and also pass that into Naka. And okay, for some reason my Defender is complaining that Windows is not activated. We can just ignore that. But I'm going to go back here. And just to showcase what this actually did, when I go into Naka, output x64 release, you can see we have these files here that Naka created. These are .cd and .key files. So once we have all of these files, we need to run naka64.exe --stable. And this will generate two more files here, secrets32.bin and secrets64.bin. And now we need to copy these files over and give them to Akagi. And just for a bit of context, right? Akagi is the actual final executable that we're going to be running to basically invoke these various UAC bypasses, right? So we're gonna go in Akagi and then bin, and you'll see we have these files here. They're all 0 kilobytes. So we just need to replace them. So we're gonna take all the .cd files, and we're gonna take the bin files, and we're just going to, you can either move them or copy them. I'm gonna copy them into this folder and replace the files in the destination. And once we have all that, we can just go here into Visual Studio and then build Akagi. And you can see that succeeded. So now we can go into output x64 release, and you can see we have akagi64.exe. So this is the program that we're going to use to bypass UAC. So the way that you actually use it is you need to first pass in a number which represents which bypass method is going to be used. I'll do 23. And then optionally, we can pass in which program we want to actually run as administrator. I'm not going to pass in anything, and you'll see that this is just going to give us an administrator command prompt. So when I run it, we get administrator command prompt. We actually get two of them for some reason. But you can see that these are in fact admin command prompts, and there's actually no UAC prompt, right? You saw we didn't get any UAC pop-up. I'm going to try a different method like 61, and you can see we get an administrator prompt once again, and there's no UAC. We've completely bypassed it. So that's all you need to know about bypassing UAC on Windows. I hope that you did enjoy this video, and if you found it useful, then please leave a like and subscribe for more videos like this one, and I'll see you in the next one.